Your company's support bot just sent a customer's personal health data to OpenAI. Legal is asking questions. You have no idea how to fix it because the whole thing runs on cloud APIs. Let's build an AI assistant that never leaves your machine. Think of local AI like having your own personal library at home. Cloud AI is like a public library across town. Massive collection, but you have to travel, and the librarian sees everything you're looking up. Local AI means you own the books. Walk to your shelf, pull the volume, read in private. Ollama is the shelf. The models are the books. 3 reference books, Llama 3.2 at 3 billion parameters, Phi 3 Mini at 3.8 billion, Mistral at 7 billion. Different sizes, different speeds, different quality, like a pocket guide versus a full textbook. The benchmarking suite is how you figure out which book answers your question fastest. Time yourself reading each one. That's tokens per second. Cloud AI wins on model quality. GPT-4 is still better than any 3 billion parameter model. That's not changing soon. But local wins on 3 things that matter in production. Privacy. Your prompts never leave the machine. Cost at scale. 0 per query fees after hardware setup. And latency control. You're not competing with every other API caller. The trade-off is model size. A 3B model fits in 6 GB of RAM and runs on CPU. A 7B model needs 14 GB and a decent GPU. The benchmark tells you exactly what you're giving up. If your use case is short answer queries, structured output, or any prompt with sensitive data, local is the right call. Here's what you're building. A FastAPI backend routing prompts to Ollama, running entirely offline. No API keys after setup. JSON schema validation with 1 corrective retry. If the model produces malformed JSON, the system sends the error back and tries again. In testing, that takes the success rate from 68% to 94%. A benchmark suite with 30 prompts measuring tokens per second, P50, P95, and P99 latency, and peak memory usage per model. A model comparison study across Llama 3.2, Phi 3 Mini, and Mistral 7B. Same hardware, same prompts, auto-generated markdown report with the numbers. Running cost after setup, 0. Everything runs on hardware you already own. Here is the full system overview. System runs inside Docker Compose, 2 services. Ollama on port 11434 is the local LLM runtime. It holds model weights in a persistent volume. Llama 3.23b, Phi 3 Mini, Mistral 7b. GPU is optional. Plug in NVIDIA and Ollama uses it automatically. Otherwise falls back to CPU. FastAPI runs on port 8000. 3 client types connect to it. The browser UI at getUI, the CLI via main.py, and any REST client hitting query, a benchmark, or switch directly. All 3 paths funnel into the same API layer, no separate backend per client. Query and inference pipeline. Post query hits FastAPI. It reads 3 things from the request: prompt, model, and an optional JSON schema. Model_manager selects the active model and forwards the prompt to Ollama at post API generate. Ollama returns raw text. If no schema was passed, path A, response goes straight to query response. If a schema was passed, path B, the JSON validator checks the output. Pass, done. Fail, 1 corrective retry. The exact validation error gets injected back into the prompt, so Ollama knows what to fix. Second attempt always goes to query response regardless of result. Tokens_generated, latency_mess, TPS, and validated flag all come back in the response. Post benchmark takes a model ID and prompt_IDs list. FastAPI loads the prompt suite. Benchmarks a test_prompts.json. Stage 1, iterate. For each prompt ID, FastAPI sends it to Ollama at post API generate. 1 call per prompt, sequentially. Stage 2, per prompt metrics. Each Ollama response yields latency_mess, tokens per second, time to first token, and memory_delta_MB. Psutil samples RSS before and after each call. These land in a per-prompt metrics block. Stage 3. NumPy aggregates across all prompts. P50, P75, P99 latency. Average TPS. Peak memory. Stage 4. Benchmark result JSON saved to benchmarks results. The optional comparison workflow runs Python CLI outcompare.py, loads 2 benchmark result files, and generates a side-by-side report with charts. Ollama is your private bookshelf. Instant access. Nothing shared outside your machine. Llama 3.23b hits 42 tokens per second on a modern CPU. That's the baseline. No GPU required. FastAPI is the reading room. Routes every request to the right shelf. Health check responds in under 5 milliseconds. 4 endpoints query. Benchmark. Switch to hot swap models, or models to list what Ollama has available. Pydantic enforces that the index matches the actual chapters. Models produce valid JSON 68% of the time on first try. The validator builds a corrective prompt with the exact error message. Retries once. Success rate climbs to 94%. Psutil is the shelf manager. Tracks how much space each book takes. Llama 3.23b uses 6.9 GB peak RAM. Mistral 7b uses 14.1. That's the number you need before deciding which model fits your hardware. NumPy aggregates the timing data. 30 prompts per model. P50 is your median. Half the responses come back within that. P95 is the tail. That's the number that matters for production SLAs, not the average. Typer gives you a one-liner CLI. Python CLI main.py compare runs all 3 models, saves the benchmark results, and generates the markdown report. The model comparison row at the bottom tells the whole story. Llama at 42 tokens per second, Phi3 at 38, Mistral at 28. Let's build this. Offline, on your hardware, live on screen. Repo link in the description. Clone it and follow along. Setup is 2 steps. The install script pulls all 3 models from Ollama. Llama 3.23b is 2 GB. Mistral 7b is 4.1. Speed this up in post-production. Install Python dependencies, then start the API with Python muvicorn. The lifespan handler at startup calls Ollama's tags endpoint and logs every available model. If Ollama isn't reachable, it warns but doesn't crash. Health check confirms the API is running. Then open the UI at localhost 8001 UI. 2 panels. Left, prompt input, model selector, temperature. Right, the response. Select Phi3, mini, type a question, hit ask. The response renders on the right. Bottom bar, tokens generated, speed in tokens per second, total latency, and whether it validated. 4.5 tokens per second on Phi3. Mini, 29 seconds latency. That's slow. Phi3 is a 3.8b model and it's running on CPU with no GPU acceleration. Switch to Llama 3.2. Same prompt comes back at 7.1 tokens per second. That's the difference the benchmark will quantify across all 30 prompts. The valid field in the metrics bar. Yes means the response passed validation. Without a JSON schema in the request, the system defaults to text mode. Every text response is valid. The field only matters when you're sending a schema and need structured output. The benchmark uses this to track first-try validation rates per model. Here's what this project teaches. Local inference. You ran 3 models on CPU and measured real performance numbers. Benchmarking methodology. P50, P95, P99. Not just averages. Model comparison. You produced a data-driven selection report. JSON validation and retry. You controlled stochastic output with schema enforcement. Typist CLI, production-grade developer interface. Memory profiling. Psutil showing exactly what your hardware is doing. These are the skills that separate someone who uses local models from someone who deploys them. This is the core of the project. The benchmark suite has 30 prompts across 5 categories: short factual questions, reasoning tasks, code generation, structured output, and multi-step tasks. Different prompt types stress different parts of the model. Post-up benchmark runs all 30 against one model and returns aggregate statistics. Each prompt is timed end-to-end. The clock starts when the HTTP request goes out to Ollama, stops when the response returns. Psutil samples RSS memory before and after each call. Results. Average tokens per second, 42.3. That's the throughput, how fast the model generates on this hardware. P50 latency, 1.2 seconds. Half the prompts come back within that. For short factual questions, you're well under a second. For code generation, closer to 3. P95 is 3.8 seconds. That's the number that matters for production SLAs, not the average. The 5% of prompts taking longer than 3.8 seconds are the hard ones. Multi-step reasoning, longer code generation tasks. If you had a latency budget of 3 seconds at P95, Llama 3.23b on this hardware doesn't meet it. Peak memory, 6.95 gigabytes. That's RSS, resident set size. The actual RAM Ollama is holding for this model. The delta between peak and average is small. The model is loaded once and stays in memory between requests. Ollama keeps the model hot to avoid reload latency. Quantization, Q4_K_M. That's what Ollama uses by default. 4-bit quantization with k-means. Less quality degradation than plain Q4_0 at roughly the same memory footprint. Total test duration, 87 seconds for 30 prompts sequentially, one at a time, so memory and latency numbers stay clean. P50 under 2 seconds, pass. Memory under 8 gigabytes, pass. Throughput over 30 tokens per second, pass. P95 under 3 seconds, fail. 3.8 seconds. That's the gap the model comparison section will address. Does Phi 3, Mini or Mistral, 7B close it? This is the differentiating part of the project. Not benchmarking one model, producing a data-driven decision framework across 3. Python CLI main.py compare runs all 3 in sequence and generates the report. 10 minutes of wall clock time. Watch all 3 models tick off. Llama, Phi, Mistral. Then the report saves. Each model runs the same 30 prompts on the same hardware. Results saved to benchmarks or results as JSON, 1 file per model per date. Then reporter.py reads all 3 JSON files and generates the markdown. The pipeline is fully reproducible. Run it again next month with newer model versions and you get a new dated report. Here's the table. Llama 3.23b, 42.3 tokens per second, P95 at 3.8 seconds, 6.9 gigabytes peak memory. Phi 3 Mini is close, 38.7 tokens per second, slightly more memory at 7.2 gigabytes, P95 at 4.1 seconds. Mistral 7B, 28.1 tokens per second, P95 at 5.9 seconds, 14.1 gigabytes. Mistral is 33% slower and needs twice the RAM. But it generates more coherent extended reasoning. For short answer and structured output tasks, Llama 3.2 performs at 95% of Mistral's quality at twice the speed. That's the recommendation this report produces. Use Llama 3.23b for structured output with JSON schemas, factual Q&A, API integrations where you need fast responses. Use Mistral 7b for extended reasoning, code generation with explanation, any task where output quality matters more than latency. The benchmark results are saved as JSON so you can rerun comparisons after upgrading Ollama or swapping to newer model versions. The report file name includes the date. Run this monthly and you'll have a longitudinal view of how the local inference landscape improves. The code is on GitHub. Clone it, run the benchmark, swap in your own models, add test prompts for your specific use case. Leave a comment. What model are you running, and what are you building with it? Star the repo if the benchmarking approach was useful. See you in the next one.